Today we're going to be graphing f of x equals ax squared plus c, starting with the state standards given here. And to be successful today, you need to be able to graph a quadratic function of the form f of x equals ax squared plus c. You also need to be able to compare the graph of f of x equals ax squared plus c to the graph of the parent quadratic function. You need to be able to describe translations of the graph of f of x equals ax squared plus c, and you need to be able to find zeros of f of x equals ax squared plus c. Only one vocab term today. Make sure this is in your notes and you get familiar with this. You will see this term throughout the rest of the year. All right, a zero of a function f is an x value for which f of x equals 0. A zero of a function is an x-intercept of the graph of the function. All right, so 0 is another word for solution. The x-intercepts are where the quadratic function crosses the x-axis, so that's why it's f of x equals 0, and those are called your zeros of the function. So your x-intercepts and zeros are very similar. All right, key idea, graphing f of x equals ax squared plus c. You can see here the line in blue is your quadratic function, your parent function for this purpose. And if c is greater than 0, you can see that whole graph gets shifted up. If c is less than 0, you can see the whole graph got shifted down. So it's the same shape, same kind of function. It just gets moved up or down depending on what c is. So this is called a vertical shift of k units. All right, so again, a vertical shift plus k moves it up. If it's minus k, it would move it down. All right, example 1, graphing y equals x squared plus c. All right, in this case, g of x equals x squared minus 2. Compare the graph of the parent function. All right, it says, remember, the graph of y equals f of x plus k is a vertical translation, and the graph of y equals f of x minus h is a horizontal translation of the graph of f. So this is a vertical translation, which moves it down if it's minus, up if it's positive. So let's see, I've already got the parent function in black, and we're going to take the red graph and make it x squared minus 2. So I'm going to take the entire graph. I'm going to try to take the entire graph here and move it down 2 units. So you see I just took the entire graph, same shape, same size, same everything, but now the vertex is at -2 instead of 0. All right, so to graph x squared minus 2, you're going to take the parent function and shift the whole thing down 2. It's that simple. This goes to show you that it is important to know what the parent function looks like, because if you know what the parent function looks like, then it's very easy to get to the new graph. You don't have to have a table of values. All right, for example 2, we are going to use a table of values. You can see that I already have f of x equals x squared, or the parent function graphed, but this time we have 4x squared plus 1. So a is 4 and c is 1. So in order to graph this, we're going to quickly make a table of values, and it will help us determine where some of the points are that we need to graph. So you can choose any x's you want. Remember, it's independent variable, but we need to choose some on both the left and right side of 0. So we need some negative and positives. Let's just choose some small numbers to make it easy. All right, and then you have to plug your x's in to find y. So -2 squared is 4. 4 times 4 is 16, plus 1 is 17. -1 squared is 1. 1 times 4 is 4. 4 plus 1 is 5. 0 times anything is 0, plus 1. 1 squared is 1, times 4 is 4, plus 1 is 5. 2 squared is 4, times 4 is 16, plus 1 is 17. So that quickly gives us some points that we can use to graph. Again, we have the parent function already graphed here. I can go ahead and label that. Let's see, f of x equals x squared. All right, now we need to graph some of these points. So if this is over, let's see, let's do our negatives first. -2, 17 is not going to be on the graph. Let's go over -1, up 5. 1, 2, 3, 4, 5. And then I'm going to do 0, 1. And then I'm going to do 1, 5. And then again, 2, 17 will be off the graph again. So we have 3 points. We can graph a function with 3 points. So let's see if I can make this happen. Let's use red. All right, so now you can see the parent function here and then the new function. This is, red is g of x. All right, g of x is this function here. So, all right, so what can you say about the two functions? Both graphs open up and have the same axis of symmetry. X equals 0 would be the axis of symmetry. The graph of G is narrower. You can see the red graph is more narrow. And its vertex is 0, 1. So its vertex is above the vertex of f of x. F of x, the vertex is 0, 0. And the vertex of g of x is 0, 1. So the graph of G is a vertical stretch by a factor of 4 and a vertical translation 1 unit up of the graph of f. And that should make sense since this is a 4 and this is a 1. All right, example 3, translating the graph of y equals ax squared plus c. Let f of x equals -0.5, that's the same as 1/2, x squared plus 2, and g of x is f of x minus 7. So g of x is going to be this whole function down 7. All right, so it says describe the transformation from the graph of f to the graph of g. Then graph f and g in the same coordinate plane. All right, so the first thing we're going to do is find some points to graph f of x so we can see what that looks like. We know it's quadratic because it has an x squared. Remember, anytime you have a highest degree of 2, we're looking at a quadratic function, which is a parabola, is the shape. And then g of x is going to be a translation of f of x. All right, so let's make a table of values. Again, you can choose any x's and y's that you want. I'm going to try to choose wisely. Since this is 1/2, I'm going to choose multiples of 2 because multiples of 2 will make this come out to be a nice number to work with. So let's do -4, -2, 0, 2, 4. And again, you don't have to choose these numbers, but I'm trying to make it easier to work with. So if I have -4 squared, -4 squared is positive 16. -1/2 of 16 is -8. -8 plus 2 is -6. All right, -2 squared is going to be positive 4. -1/2 of that is -2. -2 plus 2 is 0. 0 squared is 0 times anything is 0. 0 plus 2 is 2. And then 2 squared is 4. -1/2 of that is -2. -2 plus 2 is 0. And then again, 4 squared is 16. And then half of 16 is 8. Multiply by the negative, -8, plus 2, -6. So you can tell when you have a quadratic equation, you can see how these numbers go up to this point and then back down. Because this is negative, it should make sense that your highest point is going to be your vertex this time. All right, so let's graph a few points here. So -4, -2, 0, 0, 2, 2, 0, and 4, -6. All right, let's graph that. All right, this time it's going to be upside down, so my vertex is going to be here. It may take me a minute. Hold on just a second. All right, so that is the function of f of x. I'm going to go ahead and do another one real quick. Exactly the same, so that we can just use that as a translation. All right, so now we have another function graphed on top of that one. And what we need to do is say, describe the transformation from the graph of f to the graph of g. G of x equals f, function f, minus 7. So that means we're going to take this whole graph and move it down 7. So the graph of f and g are in the same coordinate plane. All right, so if I have this one graphed, I'm going to move it down 1, 2, 3, 4, 5, 6, 7. So it's the exact same graph shifted down 7. So you can see now the vertex is at -5. All right, so that's the easiest way to graph when you have a translation. So it says to describe the translation. So the function g is of the form f of x equals, y equals f of x plus k, and k is -7 in this case. All right, so the graph of g is a vertical translation of 7 units down. And that's your description. And then it says write an equation that represents g in terms of x. All right, so if we do that, we're going to have g of x equals f of x minus 7. That's given. So we're going to have g of x equals, just substitute for f of x what it actually is. And then minus 7 is part of the function. You have to bring it down. So g of x equals, so this is the function of g that represents the red line here. Remember, I had the black line is the original function. That's your f of x. So this is f of x. And this one is g of x. All right, so if it says write an equation that represents g in terms of x, all you had to do was substitute this part of the function in, combine like terms, and that's your new function.